When we're solving system of equations, we're seeing where the two equations intersect, okay? In a lot of cases, the letters used are going to be X and Y, but if they're not X and Y, you put them in alphabetical order, and the first guy is the X and the second guy is the Y, okay? So your R would be the X, and your T would be the Y. Does everybody see that? Well, when two lines intersect, when you have a system of equations, it could look three different ways. So I'm going to draw just three little graphs off to the side. They could intersect at one point, like this, and in that case, that would be the solution right there, whatever point that is, would be the solution. They could be parallel, and when are those two lines ever going to intersect? Never, so the solution is no solution. Or they could look like they're kind of the same. They're right on top of each other. They're just in a different format, and this would be infinitely many solutions. So we're going to talk about the no solution and infinitely many in a minute. But first we're going to do one where it's got 1 point solution, okay? The way to do this is by elimination. There's going to be 4 different things I teach you. I'm going to teach you graphing. I'm going to teach you elimination. I'm going to teach you substitution. And then I have a special surprise on how to do it on your calculators. All right, so today we're doing elimination. You have to look at both letters and find a way to make one equation the opposite of the other for a certain letter. So if we eliminate the T's, and you see they're both plus T's, you see it? If I multiply this guy here by a -1, I'll get the first equation like it is, -r plus t equals 5. And the second equation will be 2r minus t equals -4. And now my t's are opposite of each other. You see that? You see they're opposites of each other, plus t and minus t? You can have a plus 2t and a minus 2t, whatever you need to do to make them opposites of each other. Now we're going to add the two equations together, and -r plus 2r is r. The t's bite the dust, and that equals 1. Oh my gosh, we already found r. In every case, once you find the first guy, you find the second guy by doing the same thing, and that is plugging in that number for r in either one of these two equations, okay? So I'm going to plug it in the first one. It's -1 plus t equals 5. Add 1 to both sides. We get t equals 6. And then I would do a little check and make sure that that makes sense. So -1 plus 6 is 5. That checks out. And -2 plus 6 is 4. That checks out also. So that's the answer. You would write your answer in an XY pair like this, 1, 6. We have to make one or the other opposite of each other. And in this case, these two p's are already opposite. So we can go ahead and add them together. And they bite the dust. Oh, wow. But the r's bite the dust too. So we have 0 left on the left equals 8. Okay? All the letters disappeared, which will happen on occasion, and it gave you a statement there, 0 equals 8. Is that a true statement or a false statement?
False.
It's a false statement, so that means there's no solution to that problem. So here the p's are opposite again, so we can just add the two together, and we get they bite the dust, they bite the dust, that's 0, and they bite the dust, so 0 equals 0. So is that a true statement or a false statement? Does 0 equal 0? Yeah, that's true. So this one would be infinitely many solutions. So that means those two lines are the same line if you graph them on a graph. Both cases, the letters bite the dust, but in one case it gives you a true statement. In one case it gives you a false statement. If it gives you a false statement, you know something's wrong because 4 doesn't equal 7 or 3 doesn't equal 2, right? So you know it's no solution. If it gives you a true statement, then it's infinitely many. It's the same line, okay? So no, you can't do that. But you can eliminate, you want to eliminate the m's. We can multiply this guy by a 3 and we'll get a 12, and this by a 4 and we'll get a -12. You see that? So now we have 12m minus 6p equals 0, and negative 12m plus 36p equals 20. So the m's now are opposites of each other, so we can eliminate the m's, and we get 30p equals 20, divide by 30, and p equals 2/3. And now we have to plug that in up here. So let's do negative 3m plus 9 times 2/3 equals 5. And you can put 9 times 2/3 in your calculator, but that's a 6. So negative 3m plus 6 equals 5. Negative 3m equals negative 1. When you move the 6 over here as a negative. Divide by negative 3, and m equals 1/3. So these two graphs are going to intersect at 1/3 because m comes before p in the alphabet, and 2/3.